Hello everybody. Today we are going to solve this statistics problem on standard deviation. This problem is part of my daily practice questions to my Facebook group and my WhatsApp group. If you're interested in joining any of the groups, please look at the instructions in the description. If you find this video helpful, please do not forget to press like and subscribe to my channel. It helps me with YouTube and only takes a few seconds of your time. Let's get started on how to solve this question. Okay, the question asks us, is the standard deviation of 10 integers, so it's given that these are integers, in a sequence greater than 0? So one property of standard deviation that we are first going to think about is that standard deviation, which is denoted by sigma, is greater than or equal to 0. It can be 0 or it is greater than 0. It is never negative because it is a square root of a quantity. The second thing we need to know is standard deviation is 0 only when all numbers are equal. So let's read through the question once more and try to understand, based on the information we have, what is the question really asking. Is the standard deviation, let's forget about the quantity of integers, in a sequence greater than 0? We know that standard deviation is either greater than or equal to 0. We also know that it is equal to 0 when all quantities are equal. So when will it be greater than 0? When some of the quantities are different. It doesn't have to be all quantities that are different, but any one quantity, if it is different than all the other quantities, then the standard deviation cannot be 0. So that's what the question is asking. It's a yes or no question. I have to be convinced that the answer to the asked question is either a yes or a no. All right, so let's start looking at the answer choices. When the number 13 is added to the sequence, the new standard deviation is greater than 0. So let's make a sequence first. So let's say n1, n2, all the way to n10 are our 10 numbers. What we don't know anything about these 10 numbers, and what statement first gives me is that I am adding 13 to this number, and not the new standard deviation is greater than 0. What does that mean? It means that all of these numbers could be anything. All we know is that 13 is different from all of these numbers, or at least one of these numbers. So if all of these numbers were 1, if I add 13 to the sequence, since I have one number which is different in the sequence, my standard deviation will be greater than 0. But the standard deviation of the sequence of all the ones is 0. Let's assume the numbers were very different. So 1, 2, all the way to 10, in which case the standard deviation is actually greater than 0. And when I add 13 to the sequence, the standard deviation still stays greater than 0. So what does that tell me in terms of yes or no to the asked question? Sometimes it is a yes, that yes, the standard deviation is greater than 0. Or sometimes it says no, standard deviation is not greater than 0, it is actually equal to 0. I do not get a sufficiently unique answer, so this is insufficient. Any answer choice that has number 1 as sufficient gets cut off. So A and D basically get cut off. Let's look at statement number B. Statement number B says the sum of the sequence is 130. So sum of the sequence is 130. There are 10 integers in the sequence. So one possibility is all numbers to be 13, which means since there are 10 numbers, the sum would be 130 and the standard deviation will be 0. Or it could be one number is 12, every other number is 13, and the last number is 14, which still makes the sum as 130. However, the standard deviation is greater than 0 because all the numbers are not same. So what does that tell us? The way we are answering the question here is sometimes the standard deviation, yes, it is greater than 0. Other times, no, it is not greater than 0. So this also is insufficient to answer the question. So B is gone. Now let's see what happens when we combine the two statements. When we combine the two statements, we get the sum is 130, and when we add a number 13, the standard deviation is greater than 0. That means at least one number in the sequence is different than 13 because 13 is making a difference to the sequence. So let's consider the sequence again. Okay, and one option we took when we stated B was if the sum is 130, then all the numbers could be equal to 13. So if all the numbers were equal to 13, in which case our standard deviation was 0, and if I add another number 13 on it based on statement number 1, my standard deviation stays 0 because all the numbers are equal. But that cannot be the case because statement 1 clearly states that the new standard deviation is greater than 0. So it can't be. So this case is not possible, which means all of these numbers are not 13, which also means that some may be 13 or some may be something different to bring the total to 130. Because see, the sum is 130. If all the numbers are 13, then the sum is 130. If you reduce one number, you will be increasing another number to keep the sum as 130, right? Which means that those numbers have to be different than 13 itself. So what that brings us to is that in all the numbers, they cannot all be 13. However, the sum is 130. To make the sum 130, some would have to be greater than 13 and some would have to be less than 13. They cannot all be 13 because when you add 13 to it, statement 1 says standard deviation is greater than 0, which is not possible. If all were 13 and you add another 13, then the standard deviation is 0. Which means that some of the numbers have to be different than 13, but still make up the sum as 130, right? So if some of the numbers were not 13 and still make up the number at sum as 130, that means some numbers are different. We really don't care what those numbers are. All we need to care about is that some numbers are different. And when some numbers are different, standard deviation is greater than 0 because standard deviation can be 0 only when all numbers are equal. Hence, the answer to this question would be C. Both statements, when combined together, would give you a sufficient answer to the question. I hope you find this helpful. If you have any doubts or questions, please feel free to comment. I personally respond to every comment on the video.